Assembly drawings. This figure shows an assembly drawing of the boring bar holder. Notice that no dimensions are given. Instead, the various parts are shown fitted together. Each part is identified by a dash number, which keys the part to a parts list. If it has many items, the parts list may be on a separate sheet. Two of the major parts in the assembly drawing have been sectioned, the body and the plate. A section drawing allows us to see how the piece would look if part of it were cut away. The slanted crosshatch lines show the cut surfaces. Many professionals will use a section drawing for specific areas. Why would you use one here? To illustrate how the screw fits into the plate? To illustrate the width of the product? To illustrate the working process of the piece? That is not correct. By sectioning the plate, the drawing shows how the screw head fits into the plate. An unsectioned plate would have shown the details of the screw head with hidden lines. The body has also been sectioned to show the post more clearly. So after having seen the details of the post, you now see the post as part of a boring bar holder. Thus, the set of detail drawings of all the components of any given assembly, plus an assembly drawing showing how it all fits together, make up the set of working drawings you use in the shop. Orthographic projections. A basic problem that must be faced when drawing an object is that objects are three-dimensional. That is, they have height, width, and depth. A drawing has only two dimensions, height and width. Artists solve this problem by using perspective. Perspective is a way of drawing things as the eye sees them. This diagram shows an example of perspective. You know the blocks have square corners, but the drawing does not show them that way. The drawing distorts the blocks. Designers have invented a way to avoid distortion and draw the surfaces of blocks in their true size and shape. How would the designer illustrate this process? Photography? Small-scale figures? Orthographic projections? That is correct. The method used is called orthographic projection. Ortho is rooted in a Greek word meaning square or true. Graphic comes from another Greek word meaning writing. Projection is the special technique used in making this type of drawing. An orthographic projection is actually a right-angle projection that eliminates the distortions in shape and size caused by perspective. It does so by ignoring the fact that things farther from the eye appear smaller. An orthographic projection shows an object from different views. For example, this diagram shows a notched block inside an imaginary transparent box. The shape of the block is projected out to each side of the box. The projection on each side shows the true size and shape of the block as seen from that direction. If the imaginary box were cut open and laid flat, you would see all 6 views of the block at once. Because only 2 dimensions are shown in any single view, to show all 3 dimensions you need at least 2 views that are 90 degrees apart. Such views are called related views. Any 2 related views will show all 3 dimensions. But 2 views may not show enough detail to make the intentions of the designer completely clear. Therefore, a set of 3 related views has been established as the usual standard for engineering drawings. If the third view adds no useful information, there is no need to show it, especially for round objects. That is why the designer did not show 3 views of the post for the boring bar holder in the detail drawing previously shown. What are the three most common points of view used for these projections? Top, front, and right, back, front, and top, or right, left, and corner? That is not correct. The three views normally shown are the top, or plan view, front view, or front elevation, and right side view, or right elevation. The object is usually drawn so that its most important feature appears in the front view. Auxiliary views. Sometimes three views are not enough. The purpose of the drawing is to show the size and shape of each surface. If a surface is not at a 90-degree angle from the other surfaces, the drawing will not show its true size and shape. The designer overcomes this problem by using an auxiliary view that is not one of the related views. The auxiliary view shows the special surface without distortion. This diagram shows the three standard views of an object. What information is still missing from this diagram? It doesn't show the holes are round, the figures are missing, or the distances are not proportional. That is not correct. None of the views shows that the hole in the inclined surface is round. To show this, the designer draws an auxiliary view of the inclined surface. This diagram shows a regular orthographic drawing of a 45-degree pipe elbow. Notice how complicated this drawing looks. This next diagram shows the same elbow with just one regular orthographic view and two partial views. Note how much simpler the elbow appears. Imagine how much easier it would be to make the elbow from this second drawing. Sections. There are times when even auxiliary views cannot show the information clearly enough. This often happens when a part has a special cross-sectional shape that cannot be shown clearly using standard orthographic views. To overcome this problem, the designer shows a section. To make a section, the designer draws a cutting plane line through the object. The cutting plane shows where the object is cut to reveal what is inside. The arrows on the cutting plane line show which cut surface you are looking at. Several kinds of sections are shown in this diagram. Pictorial drawings. There are many occasions when an orthographic projection will not show an object clearly. In these instances, pictorial drawings are useful. The pictorial drawings you are most likely to see are the perspective and isometric. This diagram compares these two kinds of drawings. Perspective drawings. These drawings are used mostly by architects. The advantage of a perspective drawing over other drawings is that it most closely represents an object as we see it. Its disadvantages, however, are that it does not show the true shapes of all surfaces, and not all parts of the object are drawn to the same scale. Isometric drawings. The word isometric means equal measure. In this case, the name refers to equal angle measurements. Isometric drawings are based on three isometric axes, which join to form three equal angles, each 120 degrees, as shown in this diagram. You know the sides of this cube are square and the circles are circles, but they are not shown that way. The position of the object changes corner angles, makes certain dimensions seem larger than they are, and changes circles into ellipses. However, each dimension is held to scale along its isometric axis. Blueprints are an important form of A. Art, B. Building. That is not correct. In a standard title block, the size of the drawing is indicated by A. A two-digit number following the drawing number, B. A set of dimensions printed in a box, C. The scale of the object represented, D. A code letter printed in a box. That is not correct. The sign-off block is used to indicate A. Approval of the original drawing, B. Revision of the drawing. That is correct. Revisions to a drawing are usually noted A. In the upper right-hand corner of the sheet, B. On the back of the sheet. That is correct. Which line below is a center line? That is not correct. In an assembly drawing, you almost never find A. A title block, B. A breakaway or sectioned view, C. Dimensions. That is not correct. A section surface is shown by A. An auxiliary view, B. Blue lines, C. Cross-hatching, D. A thin dashed line. That is not correct. Most blueprints show more than one orthographic projection of an object because A. Each projection can show only two dimensions at one time, B. Convention requires as many related projections as possible, C. Dimensions and tolerances cannot be shown in a single view, or D. Each print must show both a front view and a right side view. That is not correct. The orthographic view that shows the most important features of an object is usually labeled the A. Top view, B. Bottom. That is not correct. By using an auxiliary view, the draftsman overcomes problems of A. Too small a scale. That is correct.